Hello and welcome to my channel Infinite Physics. Today I will talk about Newton's equation F equals ma.
F equals ma is one of the most famous equations in all of classical physics, developed by Sir Isaac Newton in his famous book Principia Mathematica in 17th century. It is one of the famous axioms of Newton which revolutionized the world. F equals ma. The left hand side of the equation and right hand side of the equation joins two branches of physics: kinematics on the right hand side and dynamics on the left hand side. The dynamics is described by forces, which are of four types: a weak nuclear force, which occurs in beta decay, and strong nuclear force, which occurs in nucleus, and electromagnetic force, which occurs in our daily life, and gravity. The most basic force, Newton said that any two objects placed having mass m1 and m2, r1 minus r2, the position vectors are here, and the force is equals to g m1 m2 upon r square r roof, so it's a central force and it's always attractive. But does it really a force at all? Einstein in his paper said it's not. He, in his famous paper in 1915, Annus Mirabilis, he tells that it's not a force, it is curvature of space-time fabric caused by the distortion of space-time by mass, matter, and energy. So we are left with only three interactions that plays role in F equals MAF. The A in here is the acceleration, which is d2 or dt squared. The second, and it tells the geometry of particles and the trajectory of particles, how they will follow that path. The mass m tells the inertia of a body. And it also tells, that means the resistance to change its state of motion. So does telling the F in F equals ma tells you the trajectory of any particle under experiencing that force? The answer is no, because it's a second order differential equation. It needs two initial conditions to satisfy. The two initial conditions for F equals ma is that it needs the position at time t equals 0 and velocity at time t equals 0. Because different initial condition can lead to very different trajectories, like in here in magnetic field, and in here we get a parabola with different angle and different velocities. This implies if we have these two initial conditions, we can uniquely determine the solution for F equals ma with given F, just like a parabola in a uniform gravitational field. So like this, we can determine any trajectory of a system if initial condition and a given intrinsic force of nature is given.